Here on Earth, we can use sunscreen to help protect ourselves from the sun's UV radiation. In space, there's no atmosphere to filter out the worst of it, so you'd think astronauts would fly around with an extra rocket full of SPF 50 to protect themselves. But it turns out, UV is the least of their worries. If we ever want to get to Mars, we're going to need more than a tube of coconut-scented grease. There is UV radiation in space. The sun puts out radiation along pretty much the entire electromagnetic spectrum, from radio waves to gamma rays. Starting around UV, electromagnetic radiation has the potential to strip electrons away from molecules and cause chemical havoc. If UV light hits a piece of DNA, that DNA molecule can break and cause mutations in our cells that can lead to skin cancer. Earth's ozone layer stops the most dangerous UV radiation, but some less dangerous but still kinda dangerous UV can still get through, and that's why we need sunscreen. In space, there's much less atmosphere, so you would think that astronauts would slather on the screen. But they don't, because spaceships and spacesuits are built out of stuff that stops UV radiation. So theoretically, there's more than enough UV in space to give you the worst sunburn of your life ever, but that's the least of your worries. The real worry for astronauts isn't UV radiation, but high-energy subatomic particles, plus stuff like gamma rays. The sun gives off both electromagnetic radiation and those high-energy particles, like protons, electrons, and alpha particles. Then there is the risk of, and we are not joking, atomic nuclei from stars that exploded a million years ago. These supernova remnants are called galactic cosmic radiation, and they're mostly protons and alpha particles, plus a smattering of heavier particles, tearing through space at nearly the speed of light. Don't worry about what all these things are. There is no quiz and no homework assignment at the end of this episode, although if you want one, check out this video where we explain some of it. They're just small things moving very, very destructively fast. And anything moving at such incredible speeds has a lot of energy and a lot of potential to break whatever it hits. That could be an unfortunate astronaut, but it's more likely to be the wall of a spacecraft, at which point some of those atoms could break apart and produce secondary radiation, more protons and alpha particles or gamma rays that might hurt the astronauts inside. Here at home, we really don't have to worry about this kind of space radiation. Far beyond the ozone layer, Earth has another radiation shield, our magnetic field, and those space particles can be deflected by a magnetic field. And the fact that our planet is a giant magnet comes in real handy when it comes to bashing most of those particles right back out into space. Fortunately, although astronauts in Earth orbit, like on the International Space Station, fly above our atmospheric UV shield, most of the time they're still low enough to be protected by our giant magnetic umbrella. The risk is to astronauts who leave the protective confines of our magnetic field, say to the Moon or Mars. A round-trip flight to Mars, plus a nice year-and-a-half stay, carries with it a radiation exposure equivalent to a roughly 5.5% increase in the risk of developing a fatal cancer. So any ship that travels outside of the Earth's magnetic field, including to Mars, would need extra shielding to deal with space radiation. The best way to block protons and alpha particles is with something of a similar size. That means that hydrogen, whose nucleus is really just a proton, actually makes a very good shield against high-energy space particles. That's true even though it's the smallest element. And that's good news for space travel, because hydrogen is really lightweight, and we'd have to take lots of it to space anyway, like in the water that astronauts will need to, live and stuff. The sun produces radiation all the time, but space also has weather of a sort. Solar flares and other events can cause radiation storms that astronauts would need to shelter from. So one proposed idea is to build a sort of bunker hidden beneath the ship's water supply to hide in if a solar flare causes a radiation storm. Plastics also contain a lot of hydrogen, so believe it or not, a plastic shield is a very viable way to deal with potential radiation. But any kind of physical shielding, even nice lightweight plastic, increases the weight of the spacecraft and the difficulty of launching it into space in the first place. So engineers are also interested in developing a mini magnetic field, just like the Earth-generated one that protects us, which would basically be a force field, which would be sci-fi as heck and really, really cool. But current technology requires a huge, heavy power source to generate a strong enough field, so it's right back around to the weight problem. Radiation is just one of the many huge hurdles we'll have to get over if we ever want to go to Mars. NASA and other space agencies do care about the safety of their astronauts, Plus, if interplanetary travel ever becomes a thing, and I will be first in line if it ever becomes a thing, the rest of us will want to be safe as well. Evidently, NASA hasn't considered that extra payload full of sunscreen, so we'll let them have that one for free. One more thing. We're celebrating National Chemistry Week, which this year is all about space. If you want to join in, check out the hashtag NCW or click the link in the description to find out more. Thanks for watching. Before you go, remember to share, subscribe, hit the bell to get notifications, and tell all your friends about atoms from exploding stars in space. We'll see you next week.